Hello guys, welcome back my YouTube channel. I'm Surya Aryawan, and in this video I will learn about mathematics logic. And before that, don't forget to like, comment, and subscribe. And then so let's enjoy to learning. First, in mathematics logic, we learn to determine the value of a statement, whether it is true or false. The statement itself is divided into two types, namely, number one, closed statements, and number two, open statement. And then number one, closed statement. Closed statement or closed sentence are statements that already have true or false values. And then for example, 2 is an odd number. It's a false closed sentence. Why? Because the sentence is correct. 2 is an even number. And example number 2, 3 plus 3 equals 6 is true closed statement. And then number 2, open statement or open sentence. An open statement or an open sentence is a statement whose truth value cannot be determined because of a change or variable. And next, for examples of mathematics logic. Px equals 2x plus 2 more than h, x element r. When x equals 2, then P2 hence obtain 2 times 2 plus 2 more than h. It is false. When x equals 4, then P4 hence obtain 4 times 2 plus 2 more than h. It is true. And next, negation of a statement. Negation is the inverse value of a statement, where when a statement is true, then the negation is false. And when a statement is false, the negation is true. The negation of the P statement is denoted by negation P. And then number 2, quantor statement. A quantor statement is a form of mathematical logic in the form of a statement that has a quantity. In a quantor statement, generally, 3 are the word all, every, some, there, and part. Words that are word all, every, belong to a universal quantors, and words that are word part, some, exist, belong to the existential quantors. The universal quantors and the existential quantor negate each other. P, everyone is a scholar or universal quantors, and negation P, some people are not scholars. Number 3, compound statement. Equivalent forms and their negation. In mathematical logic, several statements can be formed into one statement using logical conjunction such as and, or, then, and if, and only if. The combined statement is called by a compound statement. In mathematical logic, these conjunctions each have their own symbol and term. You can see on the screen. Number 4, conjunction truth table. From the table, it can be concluded that the nature of the conjunction is true if the two constituent statements of the compound statement are both true. Number 5, truth table of disjunction. From the table, it can be concluded that the nature of the disjunction is false if the two constituent statements of the compound statement are both false. And this picture you can see on the screen. And number 6, third implication table. On the nature of this implication, if P then Q. P is called the hypothesis and Q is the conclusion. In this implication, it will be false when the conclusion is false and the hypothesis is true. Number 7, third B implication table. In the B implicative nature, the compound expression will be true if the two constituent statements are the same. Both are true or both are false. Number 8, tautology and contradiction. Tautology is a compound statement that is always true for all the possibilities, and contradiction is the opposite. That is a compound statement that is false for all the possibilities that exist. Number 9, equivalent form of compound statement. Compound statements that have the same value in all possibilities are said to be equivalent. The equivalent notation in mathematical logic is the form of statement which are mutually equivalent are. The picture you can see on the screen. And number 10, compound statement negation. Compound statement negation is conjunction negation equals negation P and Q equivalent negation Q or negation Q. Disjunction negation equals negation P or Q equivalent negation P and negation Q. Implication negation equals negation if P then Q equivalent P and negation Q. Negation B implication equals negation if P then Q equivalent P and negation Q or Q and negation P. Number 11, conversion, inverse, and contraposition. Conversion, inverse, and contraposition are other forms of implication where the conversion of if P then Q is if Q then P. The inverse of if P then Q is if negation P then negation Q. The contraposition of if P then Q is negation Q then negation P. And number 12, conclusion drawing or mathematical logic. Drawing of conclusion is the conclusion of several compound statements or premises that are interrelated. In drawing conclusion consists of several ways, namely A. Modus ponens, you can see on the screen, and B. Modus tollens. And then, for example, 1. Premise 1, if Lala likes to eat chocolate, then Lala is fat. Premise 2, Lala likes to eat chocolate. The conclusion of the two premises above is answer premise 1 equals if P then Q. Premise 2 equals P. Conclusion Q or modus ponens. So the conclusion is that Lala is fat. Alright, that is all about topic today. Thank you for watching. I hope this is useful. Enjoy your day and thank you.